Well, this is hopefully part two of my Endstops and Explanations project, and I'm going to try to do a little bit of a lab today to definitively show how the endstop works and how your firmware settings affect that. I have to do a little bit of catch up here. I left off one thing from last week, so I will jump into that. Now, I did a little bit of research on this because it didn't make sense to me at first, but historically, early on, people, and apparently later on too, but people would connect your end stop connector to the normally closed connector of your end stop switch. So what does that mean? A switch like this, and I'm just going to draw this out. And let's see, here is my actual switch button, and here's my rocker arm with a roller on the end. And I've got three connections on this, three electrical connections. A common, a normally closed, and a normally open. So I'm going to draw this electrically. There's my common lead connected to my normally closed. Normal meaning not actuated, just sitting idle. And I've got a normally open contact not connected to anything. As soon as I close the switch, my common lead now changes over to my normally open lead and makes that a circuit between the common and normally open. If I let off the switch, my switch then changes back from common connected to normally closed. Why is that relevant? Because early on, people had a lot of problems with controllers and end stops and picking up noise in the end stops. So the short answer, oh, I didn't need to erase that, but there's my plus, minus, and signal. The short answer to this is that if I were to simply connect a switch that was normally open to my signal and my ground, and I had some kind of problem with my, well, let me back up. Normally, if I have an axis that's moving towards my end stop and it hits my switch, and when it hits the end stop switch, it closes that connection, and the controller knows that the end stop has been triggered and it won't let the axis move any farther, or shouldn't move any farther. If I have a normally open switch here, and I've got some kind of problem with my wiring, maybe a wire broke or my connector came off, any number of problems, and I drive my x-axis and it hits my switch, closes my switch, but because I've got an open in my wiring, it still doesn't know, the controller doesn't know that the switch has been closed. It's going to keep on driving that axis into the side of your printer, trying to see the end stop. And you could damage your printer, you could damage your hot end, your printer is not designed to be driven that way. So obviously this would be a bad deal. It's a bad situation. So what people would do is wire that end stop switch in the normally closed position with normally closed contacts. So now if my axis is moving and it hits my switch opens up. There we go, open circuit. My controller still sees a state change. It now goes from a low to a high, but you have to invert the signal in firmware to say I now want a high instead of a low. But the open contact is now considered triggered. You just, again, have to invert it in the firmware so that you still get the same type of response. The firmware still says, okay, my end stop is triggered. Here's the advantage to this. Sorry, I'm rambling. If I have a broken wire in my circuit like before, and I wire my switch with the normally closed contacts, my controller thinks my end stop is open all the time. It's not going to let me drive my axis in that direction because it thinks I'm at the end stop. Obviously, I've got a problem. It has to be resolved, but I'm not going to keep driving the axis into the side of my printer and possibly break something. So that's why I believe, and I've never seen this written as clearly as I'm saying it, but I believe that by default, the ramps, the Marlin firmware expects you to connect the switch connection to be normally closed, just for safety reasons, just like what we talked about. Anytime I've ever tried to set up firmware from scratch, I've always had to change it from the default settings to invert that signal so that it would be expected a normally open switch, which is what I was using for most of my printers. Somebody correct me if I'm wrong. I believe this is the reason why it is set up this way, because by default the firmware wants you to have the safest possible configuration, and it doesn't want you to use a normally open switch in this configuration. You still can, obviously. You can change it in firmware, but it's expecting you to do it that way. The question is, can I prove any of this? That's a good question. Let's assume that I can. So, I've got a meter right here, set on the 20 volt range so I can get up to 5 volts here. And what I'm going to do is I'm going to connect my, make sure I'm in focus here, all right. I'm going to connect my black, my ground, to my ground pin there. Yeah, that's going to be hard to work with. The whole top row is 5 volt, the row below that is ground. The only ones that are unique are the third one with the signal, so I can pick my ground right here. All right, so I'm going to look at my Z max signal, and it is 0 volts right now. This is this S pin. It's 0 volts. When I look at my Z min, it is 4.67. It's about 5 volts. That's fine. It's a high signal there. So why is one only 5 volts and one is 0 volts? Well, if you go over and look at my Marlin, this is in my configuration.h file, I've got my end-stop pull-up section here, and if you're not familiar with it, anything that's got 2 slashes in front of it is a comment, so it's not actually part of the code. So I've got one of 2 options here. If I uncomment that top one that says define end-stop pull-ups, that will enable my end-stop pull-ups for all of my end stops. If you want to use certain specific ones, then you can keep that commented out and use just uncomment specific ones. So my Z min, I have uncommented that, or made that part of the code, and that's saying end stop pull up is part of my circuit here. Now, if you remember when I talked about this, I've said that I've got my plus pin, my minus pin, and my signal pin. This is plus 5 volts, this is ground, and that returns back to the controller. If I have if I read my voltage here at my S pin, my signal, if I don't have that internal resistor connected to my 5 volts, there is no 5 volts here. It's just an open pin. There's nothing connected. So I have to have that enabled in my firmware in order to have 5 volts to be able to pull it up to 5 volts. And then if I add a switch down here later, like that, now when I close the switch, it changes states from 5 volts to 0 volts. That's my state change when my switch closes. If I don't have that pull-up resistor, it doesn't pull the voltage or pull this pin up to 5 volts. That's the whole point of a pull-up. And that is why when I look at my Z max, I have no voltage there. I've got nothing. It's literally not connected to anything at all, which is reflected in my firmware that I have the end stop for Z min, or excuse me, not the probe, my Z max, there it is commented out. So I don't have the pull-up resistor enabled, so there's nothing there for me to pull up. All right, so I proved that my pull-up resistor is on and working. Now, I'm going to take, this is just a switch from somewhere, I don't remember where. I grabbed it because it has a 2-pin connector on it. It's normally open. So when I push the plunger, the contacts close. So I'm going to connect that to my Z-Max, between Z-Max and ground. And I'm going to look at Printerface. And it's going to show me that my Z-Max is triggered. If I push the button, it says it's open. But I'm going to leave my finger off the button and just keep pulling Printerface, and now it says Z-Max is open. Now it says it's triggered. Triggered. Open. Triggered. Open. I'm not touching the switch. Now if I do actually push on it and keep pulling for 119, I'm going to probably get open, 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 open. Yeah. So when I've physically connected the signal to ground, it does pull it low like it's supposed to, but you can never trust in electronics. You can never trust an open pin. You either need to tie it to a high or a low in order to guarantee that it's going to always give you what you want. See, I'm still pulling that and I'm getting open and triggered, and I'm not even, don't even have my hand on it. So this could cause you any number of problems, intermittent problems, that can be a real bear to troubleshoot. So remember over here on my firmware, in my configuration.h folder, my Z-min end stop pull-up is enabled, but my Z-max is not. So let's go look at my Z-min and see what that looks like. So I'm going to move my, I don't know if you noticed that every time I grab this board, I touch that ground connector first. Decades of working with electronics has always taught me to ground myself before I grab any board. It's just a habit I have. It's a good habit to have. It saved me a lot of times. I don't know how many times I've touched that ground and gotten a static shock because of me generating static somehow in the wintertime. But anyway, that's just let you know why I do it. All right, so I have my Z-min connected to my switch. Let's go over and pull this. Let's ignore the Z-max because we know it's just going to jump around. Z-min says it's triggered, always triggered, until I push on the button, and then it says it's open. Only look at the Z-min right now. So it's opposite of what I think it should be. And it is that way because my Z-min is set to false for my inverting, which I talked about before. That is set up, my inverting is false. And it says right up here, mechanical end stop with common to ground, and in my normally closed pin to the signal uses false here. That used to be the most common setup, and that's what I have, and that's what I have right here. That's what it's expecting me to have, is a normally closed switch. I'm going to close that switch and send a M119, and it says my end stop is open, not triggered, because in the normally closed position, that is what you would expect to see. And when my end stop when my axis hits that end stop and forces the switch open, then it says it's triggered. My end stop has arrived at the end stop location. So hopefully that makes sense as well. Now, if I go to my, what would be my Y-max right there, let's look at my Y-max. And it says that it's triggered and then open. Again, I get random results. That said triggered once. Nope, there's triggered. Same kind of deal. If I go over to my Y-max right there, I don't have my pull-up resistor in place, so it's not going to work correctly.
But let's do this. Let's take my WiMAX InStop and let's change that to true to invert that signal. And let's go ahead and send that to my, let's update my firmware. All right, well, I set my Xmax inverting to true, and I did not want to do that. It's very difficult. It's frustrating to me because when you look at your InStop pull-ups, they go Xmax, YMax, Zmax. The maxes are all together, Xmin, Ymin, Zmin. And then when you go to the inverting, it does the mins first and then the maxes. And one version of it actually did min, max, min, max, min, max. Anyway, so I want my YMax InStop to be inverted. And I also have to make sure my YMax pull up is also turned on. All right, let's try this again. All right, so got my firmware updated. I've got my YMax pull-up resistor enabled, and I've got my inverting set to true. So when I send an M119, my YMax says it's open, and it's consistently open because I've got my pull-up resistor in place. And when I close my switch, now my YMax is triggered. So those two things really messed with me early on, trying to figure out why I couldn't get my InStops to work consistently. And that proved to be the biggest reason for it right there. But now I understand what's happening. Now I understand how to manage them, so it's really been helpful. Oh my goodness, how could I talk for so long and still not be done? All right, I'm calling this part 1, and I'm going to make a part 2 talking about different types of sensors and switches that can be used as end stops on your Arduino-based printer. So talk to you later.